YouTube, this is Ohio Preparedness, and today we're going to be talking about solar power and the Inergy Apex, which I'm sure you've seen a lot of videos out there about. And we're going to talk about my setup here and how I'm going to support, at least initially, 400 watt panels. I got these off Amazon. They're from Rich Solar, and they're 100 watt polycrystalline panels. For the connectors, I've got, because these use by default the MC4 connector, I've got a couple of MC4 connector cables here, and I'll be connecting these in parallel. The reason for that is the Inergy is a 12 volt system, and it supports a maximum open circuit voltage from solar of 26 volts DC. Each panel puts out about 17 to 18 volts DC. So if I was to put them, even two of them in series, I would exceed the voltage of the MPPT charger in the Inergy Apex. So you really are limited to just parallel operation, and that's fine for the purposes of this unit and what I'm doing here today. So the connectors, let me set this down here. The connectors that I'm playing with are the MC4 parallel connectors. I got these from Boge RV, and they're designed so you can hook up 4 panels to each MC4 connector. So you've got 4 connectors here and 4 connectors here, and on the panel, when I plug these in, they are labeled positive and negative, so that you'll hook up the positive to one and the negative to the other and keep them in parallel. So what I have here, and you can look at the nameplate data here, but I've got the MC4 connectors. The connector on the right has the positive sign, and the connector on the left has the negative. So this represents the positive, and that represents the negative. And we'll just show you here quickly how these connectors work. They've got the plastic clips here that slides in. So basically you slide it in and they clip into place, and they're designed this way so as they're not to come apart. So actually to open up this connection once it's made, you're going to have to use one of these little plastic tools here, and you basically push the tool in and it will compress these prongs, and then you slide it out. So you basically go like this, there we go. So you can see I've attached it here, I'm holding it, and then pull, and they come right apart. Okay, and again, this just fits in here and compresses these so that you can pull it out. Pretty simple and straightforward. Okay, so I've got the first panel hooked up there, and if we take a look at the Inergy, it says we're charging at about 56 watts. Let me see if I can rotate this so you can see that better. So we're charging at about 56 watts. Okay, so now we've got all 4 panels hooked up, and you know, they pretty much just barely fit side by side with those 2 parallel connectors. Probably, you know, when I go around to actually mount these, I'll probably want to get some short MC4 connectors just to extend them a little bit. But I was able to get all 4 connected with those 2 pigtails. And you can see that coming back here to my Inergy. And right now, we're doing about 170 watts with those 4 panels. And keep in mind that the sky is partly cloudy. I don't have the panels directly facing the sun, and they're not at an angle facing the sun based on my latitude. So these are not at the optimum position at all. I basically wanted to make sure that each panel does provide power, and to test the cable that I recently soldered, and that would be this cable right here. If you recall, this is the one I just recently soldered, and I wanted to make sure I'm getting about 190 watts. So about 190 watts on the Inergy right now, and that's really good. I mean, that's basically almost 50 watts per panel, and they're not facing the sun directly, and they're not angled towards the sun either, so I'm really satisfied with that. So the last thing I was going to show you here with these 4 panels plugged in was I was going to take a current measurement, the DC current measurement, but unfortunately the cheap clamp-on ammeter I bought was about $10 too cheap, and this one does not do DC current, it only does AC current. So I will have to upgrade and get a different one, I guess. But we are doing with 4 panels right around 180 watts, give or take. And we started at 75%, or actually we started around 73% capacity, and now we're at 85%. So this is charging very quickly, this IPEX Energy. Again, not in direct sunlight and partially cloudy days, and the panels are not angled towards the sun like they should be. So I'm nowhere near getting peak efficiency out of these panels, but that's task for another day. I'll see what I can get when the sun's overhead, and I'll try to properly angle these towards the sun and get another reading on that. One thing to keep in mind is the MC4 connector has a limit of 20 amps at, I think it's 600 volts. We're only doing about 18 volts, but we've got 4 panels in parallel. So if you use the formula pi, power equals current times voltage, a 100 watt panel divided by 12 volts gives you X amount of current, which will be, I guess, around 100 divided by 12 is something like 8 or 9. When you multiply that times 4 panels, you come up with 400 watts divided by 12 volts, and you get about 33 amps. So if all of these are operating at max voltage, or I mean max power, 100 watts each, I would exceed the current rating of the MC4 connector by quite a bit. Right now, that's why I was kind of hoping my clamp-on ammeter would work. Right now at basically, you know, half power, 190 watts give or take, I imagine I'm probably pushing, you know, 16 amps give or take, which is just fine, but I wanted to actually get a measurement on that, so I'll do that at a future date. And just keep in mind, if you want to use the MC4 connector for 4 panels like this, you really need to replace the connector. So what I did at this end was I put on the EC8 connector so I could connect it, and that's a high amperage connector. It's rated for, oh geez, I think it's more than 40 amps it's rated for. It's rated for quite a bit. So what I can do, because the cable here is 10 gauge cable, and that's rated for 30 amps, I can cut and replace right there. I can cut and replace those two MC4 connectors on my pigtail, and I can replace them with a pair of EC8 connectors on each cable, and then at least I'm legitimately ready for 30 amps as rated by the wire. And the chances of me pushing a full 33 amps, getting a full 100 watts per panel, is really never going to happen. So by replacing these with EC8 connectors, I'd be absolutely fine. The pigtails are 12 gauge wire, but each pigtail is only for one panel. So 12 gauge wire is good for 20 amps, and each panel is only going to put out about 9 amps or so at rated wattage. So really all I need to do to continue using these and get maximum current is just replace those two connectors with EC8s, and that's something that I will do once I take some current measurements in the future and verify exactly what I'm getting.